the class example number 1, found on page 291 in your book, and looking at the quadratic function and equation. And in this book, we're going to connect zeros, roots, and x-intercepts and talk about what those are. So first, we're going to look at class example number 1, and we're going to be looking at the investigations in a little bit more detail tomorrow. So first of all, if I find the zero of the function where f of x is equal to 7x minus 21, what we're looking for when we're looking for the zero is the point at which this function is equal to 0. And so if I set my f of x equal to 0 and then solve my equation, I'll have something like this. And if I solve for x, one way I can do that is by factoring this. And so if I factor out a 7, I'm left with x minus 3. And finding my 0 or my x, all I would do is have x minus 3 is equal to 0. Then solving for x, I get x is equal to positive 3. So the zero of the function is the zero of the function is equal to 3. So I've skipped ahead to page 294, and in page 294, this is assuming we've gone through the investigation and built that connection to the zeros, the roots, and the x-intercepts. But what we find after those investigations is the zeros of the function, the x-intercepts of the graph of the function, and the roots of the corresponding equations when y is equal to 0 are the same numbers. So if we look at this graph of the function f of x is equal to x squared minus x minus 6, the graph has x-intercepts at -2 and 1, 2, 3 and positive 3. And the y-intercept here is the point where it crosses the y-axis is at -6. That means it also has zeros. So if we look at the equation here, the zeros are at -2 and positive 3. And the equation has roots also of -2 and positive 3. Now what we want to do is use our graphing calculator, and we want to use the zero feature of our graphing calculator to determine the roots of the equation. Now this is kind of review. We've done this before. So if I were to put 2x squared minus 7x plus 3 in my calculator and graph, I get something like this. And in order to use the zero function, you go to second function trace and go to option 2 and select 0. And what we want to do is look at for where x is equal to 0. And so I use left bound, right bound, and then I guess where x is equal to 0. And when y is equal to 0, and I get x at 0.5. And I have another place where it's equal to 0. And again, we got to use our 0 option. And it's at this point here where y is equal to 0 and x is equal to 3. And all I did was I looked at the intercept of where my graph was crossing the x-axis to determine those roots. Now we want to use the x-intercepts of the graph of y equals 2x squared minus 7x plus 3 to factor the expression 2x squared minus 7x plus 3. And so my x-intercepts were equal to 0.5 and positive 3. And so if I use those as factors of x, and so x minus 0.5 and x minus 3, so 2x squared minus 7x plus 3 would be equal to 2 times x minus 0.5 and x minus 3. If we factor this back into my equation, I would get 2x minus 1 if I FOIL that in, and then x minus 3. And that's what our factored expression would look like. If we were to draw this, I have an x-intercept there, as well as at 3. And then if I take this down to my minimum point, it's close to 2, or x equals 2, and close to y equals 3. So it's pretty close to down here. And then if we look at where it crosses my y-intercept again, and we'll look at the specific functions we'd use in our calculator later on, but it kind of looks something like this. This is just a rough sketch. Now carrying on, in order to find the roots algebraically, all we need to do, again, this is kind of review, we've done something similar to this, is set up our equation equal to 0. So I have to subtract by 33 on both sides of my equation, and that would equal 0. And from here, I would need to factor, and again, that's equal to 0. And so what multiplies to give 33 adds to give 8, we would have x plus 11 and x minus 3. And our roots would just be the opposite sign, so negative 11 and positive 3. Sometimes they'll already be factored for you. In this case, my factors would be negative would equal negative 5 over 4 and positive 3. 2x squared minus 8. If I factor out this 2, I'm left with x squared minus 4 equals 0. And I would have 2 difference of squares, x plus 2, x minus 2. And so my zeros here, or sorry, my roots would be negative 2 and 2. For this last class example, what we want to do is sketch the graph of the function, and we want to find the zeros of the function as exact values, and then we want to write the function in factored form. So, first of all, if I were to graph this, we would have 3x squared plus 4x minus 7. And here we could use our 0 feature. And before we do that, I'll just draw the rough sketch. And so my rough sketch looks something like this. Now we can use our 0 function. So we do second function, and we choose option 2. And it asks me for the left side of my graph, and then it'll ask me for the right side. And I press enter on both of them, and then it asks me to guess where that 0 is. And it looks like it is that x is equal to negative 2/3 as an exact value. X would be equal to negative 7/3, or 2.33 would be 7/3. And my other 0 looks like it's at 1, but let's use our 0 function just to double check. X equals 1. Now in factored form, what we're going to have here for the zeros of our function as exact values, we plug it in like this: 3x plus 7 over 3 and x minus 1. If I distribute my 3 in, I would end up with 3x plus 3 times 7/3 is going to be 3, or sorry, not 3, it's going to be 7, x minus 1. With this example, we have a cubic function. So the degree on my highest, with my highest degree is 3. So when we type this in our calculators, 4x to the power of 3 minus 7x squared minus 4x plus 7. And here we'll get our function. Looks something like this. And now, if you look, I have 3 points where we're crossing the x-axis. And so 3 zeros there. So x is going to equal, using the trace function again, we'll guess the left side. X is equal to -1. It looks like we're at +1, but again, let's use the 0 function to be sure. +1, and x is equal to, let's see, our last position, 1.75, which would be the same thing as 7/4. So 7/4 as an exact value. Now, in order to get our function in factored form, here's my 4. I leave out. I have x plus 1, x minus 1, and x minus 7/4. And I'm just going to multiply my 4 into my x minus 7/4, and that's going to leave me with x plus 1, x minus 1, and 4x minus 7.